Okay, so this is going to be the final example that we're going to use of projectile motion, and this is going to be based off of video 3N, which is snowball off cliff. And we're going to start with some different information. Okay, the information we're going to start with is we're going to say that the ball gets thrown in the video. It gets thrown initially in a direction like this, and we're going to make an estimate that is about 15 meters per second, and we're going to make an estimate that it was about 35 degrees. Okay, so now if I have my horizontal chart and my vertical chart, okay, I know that my vertical acceleration is negative 9.81 meters per second squared. I know that my horizontal acceleration is 0 meters per second squared. And what else do I know? Well, where do I plug in this 15 meters per second? Do I plug it in here or do I plug it in there? The answer is I don't plug it in either of those places. What I need to know is I need to figure this out using trigonometry. I need to find the two sides of that triangle using trigonometry. So I'm going to say that VI vertical divided by hypotenuse is going to be the sine of theta. So I'm going to say VI vertical is going to be 15 meters per second times the sine of 35 degrees. So 15 sine 35 going to be 8.6 meters per second. So this right there, that's 8.6 meters per second, is the original vertical component of the velocity. So I'm taking this velocity that's at an angle and I'm breaking it into the vertical component and the horizontal component. And then we have cosine theta is equal to VI horizontal over hypotenuse. I'm going to get VI horizontal is going to be 15 meters per second cosine 35 degrees. So I'm going to get 15 cosine 35, 12.3 meters per second. Okay. So I can plug those into my chart. The horizontal component of how fast it's going is 12.3 meters per second. And the vertical component of how fast it's going is 8.6 meters per second. Now I can fill in horizontal final velocity. Since there's no acceleration, that's going to be the same. Now I need to know one more piece of information before I can keep going. And I think what I'm going to do is I'm just going to estimate. I'm going to say that the cliff that we threw it off of was 50 meters high. So throws it off of a cliff that's 50 meters high. So we're going to say that the vertical distance that the snowball traveled was negative 50 meters. Okay, now that's going to make some things complicated for solving for t, but that's okay. That's what we're here for. Okay, so if I want to solve for t now, how long is it going to spend in the air? I have this equation. And so that's going to be negative 50 meters equals 8.6 meters per second t plus 1/2 negative 9.81 meters per second squared t squared. Now I'm going to arrange that differently. How I'm going to arrange that differently is I'm going to write it as negative 4.9 t squared plus 8.6 t plus 50 equals 0. Now I've dispensed with units, and I really hate to dispense with units, but for this case I want to just sort of make it, I want to focus on the math and not get caught up in the units right now. This is a quadratic equation. And to solve this, we're going to use the quadratic formula, and the quadratic formula is t is going to be minus b plus or minus square root of b squared minus 4ac over 2a. And so if I plug that in, I get t equals minus b is going to be 8.6 plus or minus square root of 8.6 squared minus 4 times a is negative 4.9, and c is going to be 50, and that's all going to be over 2 times a is negative 4.9. Now, watch this as I plug it into the calculator. Okay. Very critical. So, I'm going to say negative, hit that button, 8.6 plus, oh, hang on, I'm going to need all that in parentheses up on top. So I'm going to start off, we're going to have the entire numerator is going to have all parentheses, plus square root of 8.6 squared minus 4 times negative 4.9 times 50. That parentheses is going to close the square root. That parentheses is going to close the numerator, divided by, open parentheses, 2 times negative 4.9. Close that parentheses, and I get t is equal to negative 2.4 seconds. That's one of the roots. Now let's find the other root real quick. Well, it's really simple. All that typing that I've just done, I can bring back all that typing by hitting second enter. If I do second enter, everything that I just typed comes back, and I can go back and right there, instead of having a plus, I can have a minus. Now I hit enter again, and I get 4.2 seconds. Okay, and I'm not going to be able to get into this in the next 20 seconds. This has a meaning which I'm not going to be able to get into. But this is the answer we're looking for right here, 4.2 seconds. Okay, that's that video.